So in the last two lectures, we have been discussing arrays in some details, how to interact with them in functions, how to pass them to a function, how to emulate that you're actually returning them from a function by modifying them directly inside the function, right? And you already had quiz 3 in that. Today we are extending our knowledge a little bit about this. We are combining two things together, right? You remember some of you asked me about the strings in C, how to define a string in C. And then I said, to do this, actually we have to deal with arrays of characters, right? And then today, basically we are going to cover this topic, how to deal with strings in C through arrays. We actually had some examples before, but today we'll take this in more detail. Again, if someone is interested, he can look into this chapter in the book without pointers because we'll not cover pointers yet. So, one of the very first things we discussed in C, actually defining a variable, right? And then some of one of the types of defining a variable is actually having a character. We said that character is just 1 byte. You remember this in C? And by 1 byte, you have 8 bits. That means you have a maximum of how many alternatives? You have 8 bits, so it's 2 to the power 8, right? And then we said this is enough for the ASCII representation of numbers, including the 26 letters, upper and lower case, numbers, and some special characters in your keyboard. This may be not enough in other encodings, but for the ASCII one, it's actually enough, right? What is written here is actually, it's 0 to 255. Can someone say what basically this is saying? For 1 byte, you can actually have a range of values of this or this depending on the machine. But what specifically in the machine that actually will determine whether we have this range or this one? Basically, I have 8 bits. What makes them cover a range from minus 128 to 127 or 0 to 255? What is the difference here? Yeah? Yeah, we discussed this before. This is basically if you have a signed representation, this one if it's unsigned, right? Good. And then, this is already covered. This is the ASCII table. We had some examples on this. We said, for example, the A character, which is here, as the 26 integer number. Yeah.
For an unsigned variable, if you're just taking it in, but it doesn't expect an unsigned variable, you expect a signed variable, will it just treat it as a signed variable rather than unsigned, even though you created it as an unsigned?
I don't get. So you are saying if there is a function that is expecting a signed variable, but it reads an unsigned one, yeah. Right? That's what you're saying?
Yeah.
So
treat it as a signed variable?
Yeah, if it takes it as an input, assume that there is an input to a function or an input parameter that is signed in, right? That is signed in. In this case, whatever number you pass is going to be signed, even if it's positive, right? This is, I guess, what you are asking for, right? Is that correct?
Yeah.
Good. So yeah, so the function will read it as signed, even if it's actually unsigned. And actually, because you can cast from unsigned to signed, even if you pass from the caller function an unsigned number, it will actually get converted to signed one. Okay? Okay. So how to define a constant character? We already discussed this also before by having only this quotation. And then we said the way compiler is actually interpreting these constants, again with the ASCII representation, is it provides them, it interprets them as an integer value. A is 26. Remember, we had this example together. We printed out the A as a character by using the specifier %C, and then we printed exactly the same character variable, but as now specifier D, which is an integer, and then we had 26. Why? Because the compiler, by nature, will actually be able to interpret the character as an integer variable. And we said you can even actually use this as math operations. You can, for example, say A plus 1, and then this will give you B, right? Because at the end, these are actually integers. You just enter them in a different way. Good. Now comes to strings. What if I want to do something like this in C, like hello or anything, basically, but not just one character, a string, right? So what you need to do here is actually, we also discussed this trick before. You need to define this as array of characters, and then you have to end it with the null operator. Why? Because the compiler actually will not know what is the end of your string. Again, C, and this is something that is very important to know what is behind the scenes. And we discussed this in arrays. C has no bound checking logic. So for example, if you define an array of 10 elements and then you access element 11, the compiler will not check, right? And then we said this is very risky if you are going to write to such element because you are changing a place in the memory that you don't know what is it. Good? The same thing here. Again, a string is just an array of characters, and you don't know when this array will finish because you actually initialize it with a certain, you don't put the size at the beginning, you initialize it with a certain initialization, which is here the string, and then you have to tell the compiler that actually I'm stopping here. This is my array limit. The way to do this, basically the contract between us and the C compiler is the null operator. So what happens behind the scene, the compiler keeps checking your characters one by one until it encounters this null operator. By then, it knows that all these characters are actually related together, defining one string. Right? This is the indirect way of the compiler to know that you actually intend to do a string. Good? Is there any question here? Yeah. You don't need a null operator for integer arrays because basically you just specify the size. So what is different here, right? The difference between defining an array of integers and an array of characters is actually you want to interpret this array of characters as one, and we will see one example here, one entity, as one string. You need to deal with the whole array. Remember we said in arrays you cannot actually, for example, add a plus b if a and b are arrays. You cannot deal with the array as one entity. In a string, it's a very special case. You want to do that intentionally. So the way the compiler enables you, as we will see later, to do that is actually, it asks you to tell the compiler what is this entity. And the null operator is this thing. So in integers, to ask your, to answer your question directly, in integers you don't need the null operator and you cannot even use it. Because the null is a character and you are defining an array of integers, then you cannot have a character inside that array. Right? Is there any other question? Good. Dealing with strings in C is actually one of the very confusing topics. You guys have to be kind of cautious of what I say. If you have any question, let me know. So this is a tricky topic. Good. So to follow on what we said, to define a string of hello, you need to define an array of characters that ends with this null operator. Basically, /0 is the null operator. And every one of these is just one character. Good. This is the thing that is important. A character constant and a string constant are actually totally different. Because now you can say a special case of a string is a string of one element, right? If you just write x, something like this. Do I have my pen? If you write something like this, this is a constant character, right? But if you write something like this, what do you think? Double quotes means this is a string. It's a special case because it's a string of just one character. But we said by default any string in C is ending with a default character which is the null operator, right? That means this string is not equal, this x is not equal to this x. This x is a single character. It can be actually put in a single character variable. You can call a variable character x equal x, right? But this one has to be in an array, and this array has how many elements? Yeah? 2, right? X is the first one, and the second one is the null operator, right? Is that clear? Good. And again, this is touching on what we said. These are two different things. A question that may I expected to get asked this question, say, what is preventing me from actually defining a character array, a normal character array, without adding the null operator? I can do this in C, right? Because you can have an int array and then do 1, 2, 3, 4. You can have a character array of HELLO, hello, and then don't put the null operator. This is still a valid character array. But the only difference is this is not interpreted as a string in C. You cannot use the string functions. We will see later we have support by the C library to deal with the strings. They will not accept this one because this is not a string. This is a string. Any string in C is an array of characters that has to finish with a null operator. This one is still a valid array, but it's not a string. Is the difference clear? Is it confusing? For example, we said you cannot add two arrays together. You cannot say A plus B if A is an array and B is an array. Later we will see, using some help from the C library, you can do this for strings. You can concatenate strings, you can actually search a string in a certain way, but you cannot do this for character array. You can do this for myString. Good? So this one has basically a support or a definition for the compiler beyond this one. This is a regular array, this is a string. I'm trying to confirm this in multiple ways because it's very important. So if you have any question, let me know. Good. Yeah, so following on what we said, any string has to have the number of characters you want in this string. For example, hello has HELLO 5, and then the null character. So this is the size of your array, right? It's actually the number of characters plus 1, which is the null. To define or initialize strings, you will see that actually this follows exactly the same rules as normal arrays, because at the end it's an array of characters, except the null thing. You have to finish with the null. For example, to initialize an array that you want it to be string, you just write everything you have here as characters, and then you finish it with the null operator. You can do this in C, and by doing this, you are actually telling the compiler that you want this to be string, so it will be actually interpreted as this one. Good? And this is a good thing, is implicitly you can actually deal with strings in the way we used to, right? Good. Is there any question here? Good. So now, I have an array of characters, I have a string, and I want to do some operations on, right? First, we will start with the operations that don't use the support from the C library. We said you can have functions that deal with the strings in the string.h, right? It's called the header file, similar to studio.h. We have string.h or cstring.h that deals with the strings. But first, let's see if I don't have that support. For example, I give you a question that I'm telling you, do certain operation in a string without using that support. What should you do, right? Once you put yourself in this position, you should interpret strings as just normal arrays. So you can do anything in a string that is very similar to a normal array. For example, you can loop through them to check certain things, right? Now, the thing is, maybe you don't know what is the size of the array to go through. Remember in quiz 2, you had to read 15 inputs from the user, then you defined an array of 15 entries, and then you went through a loop from 0 to 14 to go through this array. If I asked you to do exactly the same quiz, but for string, so for example, I say you are going to read a string from a user, and then you have to scan this string and then print it back. Good? Now you know what would be the input string. So if it's going to be an array of characters, you don't know what is the size of the array. Previously, I told you that these are 15 elements. But now, as a user, I can input anything as a string, right? Then how to interpret the size of that string? Again, we had this trick from the compiler, which is we know that a string is ending with a null operator. So you can keep looping until you encounter the null operator. right? And this is the way to actually loop until the end of the array of characters or the string. Right? So even if you don't have the size, that's still okay, because you know when to end, right? One side question here. Given this situation, which loop type is actually best suited for this one? While, right? Because now we don't have a number of iterations, which is the best use case for for. You actually have a condition, which is saying if this character is not null, do something. Otherwise, you are done, right? Yeah. Sorry, would you raise your voice? No, this is still empty here. So this is not a valid C code, right? This is just like wondering what should we do here. And this is what I was explaining right now, is what is your condition is basically checking the null operator, right? So you do something like this. You go through a loop. Here is for loop starting from 0. Each time you check if your element in this array of strings is actually not the null operator, that means the string didn't finish yet. And you keep reading from the user, right? Good. Is there any question? Okay. So as I said, in this case, maybe for is not the best. It's still valid, right? Again, we said for and while are equally expressible. But maybe here, because you have a condition, it's better to write it in a while case, right? So you say while actually this entry is not null, keep doing something through the array. What is this thing? It depends on the question. For example, you can scan a string to search for a certain character, or to search for a certain number of occurrences of a certain letter, right? And by the way, if you go for coding interviews, a good portion of actually the tricks are related to manipulating strings, right? Because they have so many tricks to do this, and we have so many algorithms to actually do this efficiently. Why it's important? Because one example of where you need to actually deal with the strings is text recognition, right? This is one clear example, is you want to actually recognize the text, right? So you need to read it, to interpret it, but you need to do this online, for example, like online translation. This is one clear example of text recognition. But you want this to be very fast. So you want to devise an algorithm that does this very efficiently. Right? So string manipulation is a very important topic actually in algorithms and programming. Good. Okay. So one example of going through a string is, as I told you, you read something from the user as an input, and then you just calculate what is the size of this string. So you keep incrementing a counter, and basically this counter is telling you the size. By the way, do I need the size variable here? Or I can get rid of it? Yeah, but what my question further, do I even need it? If you're saying just put it here, similar to what one of the variants we discussed before. But now size is no different than the I, right? Right? So you can still use the I as your size. Okay? Just think of more efficient ways of doing this here. We didn't come into this. This is one of the functions that require a help from the C library, right? And we said, for now we are discussing the topics of what if we don't have this support, right? But you are right. I mean, basically, this size, you are implementing a size of function here, right? Great. Okay. So as I said, one of the examples, you can actually do so many things. It's just like some examples. Find the number of occurrences of a letter in M or M in a string, right? So something you can do is say, now I define this actually as a constant array, but you can use this as an input from a user. And then you do certain looping here that basically count the number of M's. I'll give you like 2-3 minutes to try this thing out and write the for loop. Again, this is not a quiz. It's just like something for you to see what maybe the code is like. And then we discuss it together. You have 2-3 minutes to try this out. Basically, you want to count the number of M or capital M in such text. Is there anyone done? For those who are struggling, what do I need here? Again, it's very similar to the previous example. I need a loop. I know when to stop in this loop, which is encountering the null operator. And this time, instead of having a counter to count the size, I'm actually only counting if I have an m, right? So again, you have to put a condition to only increase a counter if you have an m or m. Okay, so let's see. So this is the loop. I keep going through the loop until the end of the string. I keep incrementing my counter to basically go through here. But now I need another variable that actually counts the number of m and m. So I need an if condition that says if the current entry in the array is either small m or capital M, increase this counter, and at the end, you print this counter. It's very simple. Good? Do you have any question here? So, one of the targets of this course is actually get your mind flexible of actually how to address a problem fast and start coding it. I know at the beginning maybe this is actually overwhelming, especially in quizzes because you know it's actually associated to marks. But don't worry too much. This is something that I also want to say. I'll try to increase this kind of examples, give you a few minutes. These are like non-gradable chance for you to program on the spot to break this kind of fearness you guys have, right? But basically over the time we will see that you will be able to think of a problem. It's very easy. This actually you just added a couple of lines of code, right? But it's the psychological effect that actually prevents you from, oh, I have to do this in 1 minute, I'm just like thinking right now. Over time, we will come over this, and this is very important, right? Because, for example, if you go for an interview, actually now you'll have a job that depends on this, and someone is actually sitting in your head telling you, you have to do this right now, you have 2 minutes, and it's like a bigger problem. So if you don't know how to handle these things, it's actually problematic. Is there any question with regard to this one? Good? Okay. So now, one of the things we discussed for arrays is dealing with arrays in functions. I want to pass this as an input parameter to a function or change it in a function. So either read it or write into it. The main rule here is a string is nothing other than an array. So you can do exactly the same thing. You can take as an input to the function. You actually pass it exactly the same way. You don't have to put the size here. And then one difference that we had from, I don't know if someone caught this or not, but all the examples we had before for arrays, you pass the array, but we also pass another thing here, which is the size of the array. Here we don't do this. Why? Because again, given that it's actually an array of characters, string, you can still know when the array is ending using the null characters. So you don't need an extra input. Right? So we had this example last time, how to reverse an array. You can do exactly the same thing for reversing an array of characters. If you remember the example, I don't know if you remember or not, but basically what we had to do is we mirror basically our threshold is the half of the array, and then you need to basically swap each two elements from the side. So 0 with n minus 1, 1 with n minus 2, etc., etc., etc. Right? So you are just reversing your array. Here you would do exactly the same thing. So the only difference is, again, my checking limit is until I hit this 0 thing, and then the size plus 1. So the problematic thing is, last time, to do this thing that just disappeared right now, is we already knew what is n, or n minus 1, and then we decided this to be n minus 1 over 2. Right? Because we already had n. Now for strings, we don't have n. So you need to compute it first. Right? What you can do is, you have another loop at the beginning that tells you what is the size of the array, and then you do your normal operation on this size. This is exactly the same code that we had before. The only differences are like these two lines, and the reason is you need to compute the size of the array first to be able to get its half. Right? I can think of an alternative that I don't need to do this. Last time we said it's not efficient, but this time it may be actually efficient. Can someone think of that? What I do right now is actually doing two loops. One of them, let's compute. Do you guys know what is complexity of an algorithm? Not yet, I guess, right? So basically, if you have a solution, you get an estimate of how much time it takes. This is not a topic of this course. It's actually the topic of 2SI4, I guess, or 3SI4, like the algorithms course. But let's think in this abstractly. I have this solution. I want to see how much time it takes. As you can see, if you have iterations, they are very related. So it's enough to see how many iterations you do. Here, I go through the full size of the array. So if the size of the array is n, I take n iterations, and here I do half of that. So I do n over 2. So as a total, you do 1.5 n, where n is the size of the array, right? Like as just an abstract way. Last time, we only had n over 2 iterations because we just kept looping until the half of the array. Now we did 1.5, 3x more, right? It was half, now it's 3 over 2. Is there a way to actually reduce this? If you get confused with numbers, is there a more efficient solution than this one? We actually discussed it last time. Bonus mark? Yeah? It doesn't really matter, right? Because the only difference between do while and while is you just have to go through one iteration at the beginning. It doesn't really make a difference. Okay, one solution we had last time as an alternative, but it was not efficient. Do you want to say something? What is, okay. So last time we had 2 pointers. One starting from the beginning, the other starting from the end. You keep increasing this one, decreasing this one until they actually overlap, right? You remember we discussed this? We said, if this is my array, one possible way is to have I here, have j here. Each time you increase I, decrease j until they meet. And because you decrease them equally, they are going to meet in the half point. Right? But then, yeah? Exactly. How do I get that? There is no way I can get it, right? Because I don't know, I want to assign j now. But to assign j, you need to know n minus 1, right? So this is not a valid solution. Good? Right? Do you see what I'm trying to say? Yes? So this ij then, this is not a valid solution. Good. One solution, but this is actually outside the scope of the course. You guys are not required to think in that, right? If you think, what I'm actually doing here is nothing other than search algorithm, right? You are searching for a certain character in this array. But what you do here is what is called linear search. You go through elements one by one. Assume that you have a kind of a row of people that you are looking for a certain one. What you do is you start from the beginning, check if this is a guy, no, the other one, the other one, the other one, the other one. But actually this is the worst case search because you have to go through all of them in worst case before you find your null character, right? Or the one that you are looking for. This is called linear search. There are more efficient ways of doing search, right? Does anyone know an example of a more efficient way of doing it? Binary search, which it takes n over 2, right? So basically, yeah.
But you still need to know the size?
Great. To do a binary search, you still need to know the size because now you need to hop between this. Is there an alternative that I don't need the size for that? I leave this for you to think in, but this is outside the scope of the course. So if someone finds an efficient search algorithm that doesn't need the size of, let's say here is the array, in general the size of the data structure that you are searching, and it's more efficient than linear search, then come talk to me next time. Good? Okay. So one thing that is good, and here we start using the support of C in strings, but not using the string.h or the C string.h. It's still in the studio.h. You know, we talked about specifiers like percentage character, percentage G for decimal points, right? To read integers and characters or output, like read or write to the screen, integers or characters. One very good thing is actually you can still write or read from the screen strings directly. And place them, you have to place them in an array of characters, right? So here I'm defining 2 character arrays. I'm asking the user to enter a string. It's just enough, without doing any loops, to actually read it using scanf from the screen and place this in AA. There is one limitation here. There is one thing that may bug you if you are thinking in this thing. What is that? What is the problem with this code? Yeah? That's a good question. You don't, yeah, okay, that's a good question. You remember we said arrays by default are actually passed by reference, just by their name, right? So recall that actually printf or scanf is just a function, right? The AND is used if you want to pass a variable to a function, but you want the function to change it, to be able to change it. Because you pass, actually the AND is just the address of the variable instead of the value of the variable. This is why it's called pass by reference, right? We discussed this before and we'll visit it later. But basically to do that, like to have the AND, you are telling the function you can modify this variable. Why I'm using the AND with the scanf? Because scanf is going to read something from the screen and write into this variable. This is why you need the AND, right? This is originally why we use the AND. Here, why don't we use it? Because AA is an array. And we said by default, arrays are passed by reference. They are changed by default, right? So you don't need to do the AND. Do you see what I'm trying to say? In the last quiz, you guys modified the matrix itself inside the function, right? But you didn't use the AND in the input parameter. And the reason is a function can modify an array without, basically it's just by default passed by reference. Good? So this is not the problem. There is another problem here. Yeah. We don't know the size of the input string. So basically, if I already define a size here, I have to make sure that the user doesn't input something that is larger than these 20 elements. And actually, it's not just that. It has to be 19 elements because you reserve a 1 for the null operator, right? Do you see the point? So basically, the thing here is, yes, you allow the user to input a variable number of, like basically a string that is not known beforehand, but you have to put a limit on that size. And one very clear example of this is, just one second, one very clear example is passwords, right? Usually you can put whatever password you'd like to do in any website, but the website tells you that you have a maximum of 16 characters, or like 8 characters, or 10 characters, right? So they give you a limit. If you actually they prevent you from doing that, right? You have to put a limit here, yeah. Yeah, everything here is actually just saying it's an ASCII representation, right? But this is not the limitation. The limitation is, I see what you are confused with. What I meant is not the size of the character itself. I mean the size of the string, right? Like how many characters you have in that string. Right? This is the thing that has to be bounded here because you place this in AA, but AA has a maximum size of 20. One of them is for the null. So whatever input has to be 19 or less, right? Good. And this is without the AND thing that you asked about. Good. Then I give you the example of this password example thing, that you have 8 characters maximum, like 16 characters maximum. This is done in JavaScript. How do we limit in C how many characters I read? And then truncate anything afterwards, ignore it. It's using this thing. We already had this in integers before. Basically, this is telling you what is the accuracy or how many digits digits in case of a number, or in general, how many characters you read from the screen. So 5S here means you read a sequence of at most 5 characters, and then you are done. By this, you are safe. If the user inputs more than 5, then you ignore the remaining, right? And that's okay. Good? Is there any question here? Yeah. I said you think about this and then you get disconnected, right? What I said at the end is think in something that is more efficient than the linear search, but it doesn't need the size of the data structure, which is the array here. And like, if you find one, come to me next time. Okay? Okay. So, like scanf, the same thing is for printf. You can print basically an array of, in general, a string into the screen using the specifier of like %s. Good. Okay. So, what this is saying, basically, this and this are completely equivalent, right? The reason is this is dealing with my string as a string. So basically what it does, printf function will keep printing character by character in this string internally, right? And then it will print it until it finds the null operator. Or you do it yourself. You loop through your array of characters until you find the null operator, but in this case you print just character by character. Both actually will give you exactly the same result. Right? Do you agree with that? Okay. These are some examples of how to truncate or how to deal with what we call the accuracy of the printf scanf thing, but in character language, right? So here I'm defining a string. So one interesting thing, and it's very important. You can do this in C. You can define a variable that is named string in C. The reason is, there is no data type in C that is called string. So string is not a reserved word. But in other languages that actually have an inherent support of strings, you cannot do this. Right? And this is very important to know. And you guys have to know the difference between C and C++. The TAs are telling me in the lab that they actually just submit things in C++ code. This is a C course, not a C++ course. There is a big difference. These are completely 2 different languages. There are so many intersections, but we are just focusing in C. Good? Okay. So printf this string, and then basically you say string is and then Canada, right? And then the other thing is if you say string 3 equals 0. So I have to explain this. So here my string is, I just use this one. I don't know if you guys see here, but basically Canada is an array of characters, C-A-N-A-D-A, and then the null operator, right? What I'm doing later is say element number 3 in this array, put as 0. So I go to element number 3, put as 0. 0 is the integer value of the ASCII code of the null operator. Right? So if you define a character as 0, it's completely equivalent as if you define a character as null operator. Good? Because we said before, characters can be defined either by just a character like A, or you can say a character equal to 26, and 26 is the ASCII code of A, and this gets translated directly. Good? So 0 is the ASCII code of the null operator. That means now you're actually putting a null in element number 3. Can you imagine what may happen if you repeat the same function here? Basically, the printf function, the way it operates, again, is go through, do you want to say something? The way it goes through the array of characters is keep searching until you hit the null operator, right? So if you intentionally put a null operator in between, it will just recognize that this is your string. It doesn't know that you have remaining elements here, because the way a function knows the size of a string is by hitting a null operator, right? Is that clear? Good. This is another trick that you may be able to use, or a fault that you may do. Depends on what you intend to do. But basically, the first print will give you complete Canada, because the null operator first appears after the last A, but the second one will just give you CAN, because you print CAN, you hit a null operator, you are done. Good? Is there any question? Yeah. Yeah, in this case, it's a character, not the integer representation of the character, and then it will deal with it as 0. So what your friend here is saying, basically, what if I just put 0 here? Instead of this, I just do 0, right? So here it's this. This is going to be translated into this one, not the... And if you print, what you will get is can 0 and then GA, right? Do you get that? This is just a normal character that is 0. Yeah? Not the binary, not the integer representation of the character. So there is a big difference between the 0 as a value and the null operator. I don't know if this is clear, but if you are still confused, maybe we can discuss afterwards. Okay? Okay, now we will move a little bit to use the help from the C library for supporting arrays of characters or strings. One of the functions we have is, it's called gets, and basically it reads as an input an array of characters. Good? So basically gets is something that is very similar to printf, but it's just for array of characters, and then it reads it by default from the screen. And again, it stops at the null operator. The opposite side of gets is printing something to the screen, a string, and it's called bots, and then it reads an input a string and places it in the screen. Okay? So one example is here, is this input 5 characters on a line, something that's, then you do gets A, and then now what you want to print, you are printing the last 2 elements of that string. Basically, its integer value is this. So this is your character, and this is the integer value of this character. And then both say, do we have time to try this? So you guys maybe spend 2 minutes trying this, actually. And maybe an input that you can try is again this, let's say 2SH4 X at the end. This may be your input user to try. Or let's say I just do this, A, B, because I don't know the ASCII of 4 and X. Is there anyone done? Can someone tell me what you find in the screen for a bonus mark? Yeah, what do you get? You can actually use this one. What is that? It doesn't compile? Why? Did you include stored.h? Yeah.
66, and for 5, it's just printing like the white space. The integer value is 0.
This is 0, 1, 2, 3, 4. I see. Okay. Then for 5 you get
Just the point.
blank, and then the integer value is 0. And then what else? Because we have both A here.
Yeah, it just prints to Ascii Table.
Great, thank you. Please give me your name afterwards. So basically, so your friend managed to get this here. Okay, so basically what is happening is the following, right? I write this code. As a user, I read this message, please input 5 characters on a line. I enter 2SHAB. And then gets A is reading this, put this in the A array. That means now your A array is composed of this, ending with the null character, right? And then print if element number 4 as character 0, 1, 2, 3, 4. This prints P, and then its integer value is. Remember the difference here. These two are the same, but the specifier is different. And we tried this before. Here it's printing the character itself. Here it prints the integer associated value in the ASCII code. So here it prints P. Here it prints the ASCII of B, which is 64. This is what you said. 66. Okay. And then the second line is print the 5th element. But what is the 5th element here? It's the null operator. How the null operator is interpreted on the screen as just white space, because it's nothing. And then its integer value is 0, because we just discussed that the integer ASCII of a null is 0. And then at the end, both A is going to print the fall of A, which is 2SHAB. Right? This is what you get on the screen. Is that clear? Good. Okay, so stop here. This is something for you if you are interested to read. This is just an optional thing. And okay, later, next lecture, we will see the full support of actually from the C library using strings, like concatenating strings, reading strings, searching strings, finding the size of a string. Starting next time. Thank you.